Hello, grade 7. How are you? Hope you all are safe and well. We studied rocks before, and we classified rocks into three groups. So we said the main three groups of rocks, because we have many types of them, but the main three groups that we studied in chemistry, these are igneous, sedimentary, and metamorphic rocks. So we studied about igneous rocks, and we said these rocks can form when magma cooled and solidified. And we said examples of the igneous rock, we have basalt and we have granite. We talked about also sedimentary rocks, the second group, and we said it's porous because it's made from grains, not crystals. Igneous rocks made from crystals, but sedimentary rocks made of grains, which held together less strongly than the crystals in the igneous rocks. And we said we have types of sedimentary rocks. We have sandstone, claystone, mudstone, and limestone. Today we will study about metamorphic rocks, and we will see how do they form and what are the types of this kind of rocks. So please open page 60 and grab your highlighter and follow me. Metamorphic rocks. The same but different. What about the same of these pictures? Look at these pictures. What can you see the same, and what can you see the differences between them, or the difference between them? First, we can see the color. We can notice the color. The color, one of them is white and one of them is gray. So this sculpture is made from limestone, and this sculpture is made from marble. Skilled craftspeople carved these beautiful sculpture from natural rock. The rocks of the two sculptures look and feel very different. Both types of rock are mainly one mineral, calcite. This calcite, you can find it mainly these two kinds, they have this calcite inside them. The table shows the properties of the two rocks. We have here limestone and the marble. What's the difference, or what are the differences between them? But mainly they are formed from calcite. Limestone, the color gray or cream, but the marble, usually white, often has whirling streaks or spots of brown, red, blue, or yellow. So what is the meaning of whirling streaks? It's like twisted streaks, lines. You can see them in marble. So sometimes you can find even spots of colors, because we said about the colorful rocks, they have minerals inside them. What about the texture, like the feeling? How does it feel? The texture for the limestone, surface often rough, tiny rounded grains. Gaps between the grains, fossils often visible. So we can see fossils, we can see rounded grains, we can see gaps or holes between spaces between grains. But the marble, the surface usually smooth, interlocking, evenly sized crystals, no gaps, no fossils. We can see the marble, we can feel, if we touch the marble, we can feel it smooth. There is nothing in it, and it's very hard. Okay, this is because it's formed from interlocking crystals. Okay, let's see the marble from limestone. How can the marble from the limestone? Conditions are hostile beneath your feet, just 15 kilometers below the Earth's surface. The temperature is 400 degrees. The temperature at that depth is the pressure at that depth is 4,000 times greater than the surface pressure. We all know under the Earth's crust or the Earth's surface, we have different temperature and different pressure. So conditions there is not easy. It's very hot, very it's not clear for people. For example, if they're working in mines, they can see the difference. So under your feet, just 15 kilometers, the temperature is 400 and the pressure 4,000 times greater than the surface. In some places, hot magma comes close to the surface. It heats up the rocks around it. The heat makes rocks change. So here, the hot magma from deep of the earth can make the rocks very hot, not melted. They can make the rocks near to the surface of the earth, near to the surface of the earth, can make them hot enough so they can change. The temperature can change the shape. When limestone gets hot, its atoms arrange themselves in a new pattern. So the temperature can affect the pattern of these atoms for the limestone. This makes big crystals which interlock tightly. They can get into each other very tightly. A new rock has been made. This is called marble. Okay, so this is how the marble can form. So if I asked you a question, explain the formation of marble from limestone. So you will say that when limestone gets hot, its atoms arrange themselves in a new pattern. This makes big crystals which interlocking tightly, so a new rock has been made. So this is the marble. Both marble and limestone consists mainly of one mineral, which is calcite. This is important. If I ask you what's the mineral that marble and limestone consist of, you will say calcite. White marble is pure calcite. Colored marble has tiny amounts of other minerals mixed with the calcite. So sometimes we can see white marble, and in our kitchens we are using kind of colored marble. It has spots, colored spots: green, red, yellow, blue, brown sometimes. So this is not pure calcite. This is calcite mixed with tiny amounts of other minerals, but the white one is pure calcite. Now let's go to the next page, please. Metamorphic rocks. Marble is a metamorphic rock. Metamorphic rocks form when heat or high pressure or both change igneous or sedimentary rocks. So this is a definition for the metamorphic rocks. They form when heat or high pressure or both of them change the igneous or sedimentary rocks. So this is how can metamorphic rocks form. The rocks remain solid during the process. They do not get hot enough to melt. They don't become liquid. They are still solid. So the changes happen in the Earth's crust, because we know that the Earth's crust is solid. We can find one of these cores is a liquid, not the mantle, but the crust is solid. All igneous and sedimentary rocks can be changed into metamorphic rocks. So there are many different metamorphic rocks. So we have different types of sedimentary rocks and igneous rocks, many types. So in this case, metamorphic rocks can be different, so many different. How can we recognize metamorphic rocks? Before we studied about sedimentary rocks, we said these are porous. We can pour water on them. They can suck the water in. We can see even gaps, or we can see very small pores. We can scratch them. They can be scratched. So what about the metamorphic rocks? How can we recognize it? Metamorphic rocks made up of crystals, just like the igneous rock. So that means they are not porous, and you cannot see separate grains when you look at the rock through a hand lens. Metamorphic rocks often look squashed or stripy. Some types are made up of thin layers. So why do they look squashed or stripy? Squashed because we said that they form from pressure, and stripy, we will see why we can see them stripy. So let's see the examples of these metamorphic rocks, and we will know, or we will see, why do they look stripy. Slate. Slate splits into smooth, flat sheets. This means it makes good roofing tiles. You know, we have some kind of roofs. They are using kind of rocks. These rocks are called slate. Slate, because of the pressure and the temperature near to the surface, it can split into very smooth, flat sheets. So we can cut them, we can use them for the roofing tiles. Okay, look at this picture. Slate is made up of layers. Here, we have here layers. As you can see, different layers. It's like smashed rocks or smashed surface. This fossil formed in mudstone. We have here mudstone, but inside it there is a fossil. Its shape changed when high pressure converted the mudstone into slate. So because of this pressure, they converted into slate. So you can see them here like stripy. We have here like lines, okay, or stripes. Slate was formed from mudstone. Mudstone is a sedimentary rock. It's a mixture of minerals. So even this is another reason. Mudstone is mixture of minerals, so that's why we can see stripes. High pressure underground squash mudstone. Water is squeezed out. New crystals form and arrange themselves in layers. If mudstone contains fossil, so will the slate, but they will be squashed out of the shape of shape. So look at this fossil. You can see it. It's like up, not like deep or hidden. No, it's visible because it's squashed out of the shape of the slate. So when high pressure is applied on underground, this can squash the mudstone and squeeze the water out, so it can form layers because the atoms of the mudstone can change, and in this case they can form layers. Now let's see the other type or example of metamorphic rocks called gneiss. The G is silent, so we don't pronounce it. It's like you are saying nice, but it's gneiss. It's not like gneiss. No, it's gneiss. Is another metamorphic rock. It's hard and often stripy. Look at this. Here you have like lines. Okay. It's made up of big interlocking crystals. It was formed at high temperature and pressure deep within the Earth's crust. So we can say, if I asked you what's the difference between slate and gneiss, you will say that slate formed from mudstone and with high pressure underground squashed. When high pressure underground squashed the mudstone, squeezed the water out, it can these crystals formed and arranged themselves in layers. So but about the gneiss is hard and often stripy, made of big interlocking crystals formed at high temperature and pressure deep within the Earth's crust. Now let's go to the summary of the lesson, metamorphic rocks. Metamorphic rocks form when rocks are changed by high temperature or pressure, and sometimes both of them. Metamorphic rocks have interlocking crystals. Marble, slate, and gneiss are metamorphic rocks. We have here slate is made up of layers. Hot magma makes surrounding rocks change. We said the hot magma can make these rocks change but not melt them. They can make them so hot so they can change the arrangement of atoms, but they don't melt them. Okay, this was all about metamorphic rocks. I hope you understood the lesson. If you have any question, please write it down and don't forget the yellow box to solve it as homework. Stay safe and see you soon. Bye bye.